Good morning, students. Today we are going to see with what is a free body diagram. Generally, you know what is a diagram is. So that is how we represent any particle. If it is moving or if it is stable, whatever the action it is, it will be represented by a diagram. But here we are going to see with what is a free body diagram. So what is a free body diagram is that free body diagram is nothing but it is a simple tool which is used to analyze the motion of the object during Newton's law. Okay, so this free body diagram, it is a simple tool which is used to analyze the motion of the object using this Newton's law. So we are going to use with Newton's law and we are going to analyze the object whether it is moving in the x direction or y direction, whatever direction it is, how it is moving. So that all if we analyze, that gives a free body diagram. Okay, so next is we are going to see what all it consists of, what are the steps to be taken. What are the necessary steps to be taken are, first we have to identify the force acting on the object. Then next is represent the object as a point. So this is the object, so that object will be represented as a point. And next is we have to identify the forces. So if you know that there are so many forces which are acting on any object, such as gravitational force, then normal force and nuclear force and all this. If we consider any nucleus, it has nuclear force and all this, is it not? Here also we have to identify the force. Okay, so and then we have to represent, then we have to move the object, then we have to represent the motion of the object, so how it is moving. So that all will be represented with the help of an arrow mark. Okay, so this is how we represent the diagram. So third one is draw the vectors representing the force. So vectors is the arrow mark which you are representing. Okay, then when we draw the free body diagram, the forces exerted by the object should not be included. So what the object is exerting the force, that will not be included, but on the object what are all the force, that will be included. Okay, so let us see this with the help of some examples. Only with the help of examples you will be able to understand this. First we are considering with example 3.1. Here what is the question is, a book of mass m is resting on the table. So consider this to be a table. So over this table we are going to consider that a book is resting. Okay, first we have to find what are all the forces. Next is what are the force exerted by the acting on the book. Next is exerted by the book. Next we have to draw the free body diagram. So first is what are the two forces acting on the book is, so whenever any object is lying, there will be two force which is acting on the object. Okay, so what are they is, downward always there will be a gravitational force. Okay, so downward there is always a gravitational force, and upward there is a force that is called as a normal force. So what is meant by the term normal means any perpendicular forces. Okay, so after this, so this lesson fully, whenever you consider the object, upward it has a normal force and downward it has a gravitational force. So these are the two forces which are acting on the object. Then what are the forces exerted by the book? Okay, for that we have to consider this book, the same book, and let us consider the diagram for this. This is a book. Downward there is a gravitational force, upward normal force. So this is the representation of a free body diagram. So we are representing the book as a point. Then what are the two forces we have identified? Normal force and gravitational. Gravitational force, the formula is what? mg. So I am writing it as mg. Normal force, I am just writing it as n. Okay, so these are the two forces. Then and according to Newton's third law, so what are the two forces which acts is, the book exerts an upward force, that is normal force, and next one is downward force, that is a gravitational force. Okay, so this is how we represent the book which is lying on the table. Okay, then next we have next example which you are going to consider is example 3.4. Same way, here also we are going to consider applying Newton's second law to a mango which is hanging from a tree. So we are going to see what are the forces which are acting on that mango. So choose a coordinate systems, then applying Newton's law we have to verify. Yes. So for this, first consider this diagram. Here this is the mango, and this exerts two forces, upward force and downward force, is it not? As I told you, upward there will be always a normal force, is it not? But that is when the book or any object which is lying on a table or any solid object like that. Here upward force is considered to be a tension force, and downward always a gravitational force. Okay, so upward tension force, downward gravitational force. So how we represent the free body diagram for this? So this is object, then upward we have the tension T, and downward we have the gravitational force which is represented as mg. Okay, so this is a representation of free body diagram for the mango which is hanging on the tree. Yes. So when you see the diagram for this, so we are considering x as well as y axis. What are the two forces? As I've told you, gravitational force and the tension. Gravitational force is acting downward and the tension is acting upward. Yes. The free body diagram is given by, so this is a mango, this is the tension T, this is mg. Now when you see here, this, when you are seeing in terms of coordinates, so as we know that this is x coordinate and this is a y coordinate. So when you compare this coordinate as well as this diagram, see with this y and t, they both are in the upward direction. Okay, so whenever you are considering in the upward direction, that is considered to be j, because whenever you are writing with the term y, for the term y will be writing the term as j, and for the term x will be writing it as I. Okay, here we don't have any objects which is moving along the x-axis, so we'll not be considering with x-axis, only y-axis. So when it is moving in the upward direction, it is j. Then we have also downward direction. Downward direction, it is written as minus j. Okay, so it is along the upward direction, along the y-axis, so it is written as j, and the downward direction we are writing as minus j. Same way, if you are considering for x also, this is x. Okay, x, as I told you, we have to write as a letter I. So this is along the direction, positive direction, so we are writing it as I. Then along the negative direction we will be writing it as minus I. ஸோ இதுதான் ரொம்ப 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 பேசிக். இந்த கொஷின்ஸ் எழுதுறதுலேயே உங்களுக்கு இந்த பேஸ் தெரிஞ்சாலே போதும், வில் பி ஏபிள் டு ரைட் வித் ஆல் தி ஈக்குவேஷன்ஸ். ஸோ ஃபஸ்ட்டு நம்மளுக்கு டயக்ராம் எப்படி வரையணும்னு தெரியணும். டயக்ராம் வரைஞ்சிட்டிங்கன்னா அந்த ஈக்குவேஷன். ஸோ when you are going to write the equation for this diagram we are considering. So when you are going to write the equation for this diagram, see here, this t is along what direction? Y direction. That I told you it as positive j. Is it not? Here we are writing it as minus. Why minus is? It is in the negative direction. So what is the equation we'll be writing here is t into j cap minus mg into j cap, that is equal to 0. The total force which you are considering, that will be equal to 0. So we are writing as tj cap minus, why we are writing as minus here is because this is moving in the negative y direction. So minus mg into j cap, that is equal to 0. Yes, clear with this equation? So this equation will be written in the next one, and it is given by, first we are writing F, that is force due to gravity, gravitational force. What is the formula is mg. Since it is moving in the negative direction, we are writing as minus j. So minus mg into j cap. Next t, I am writing it as t into j cap. Now we are going to add this both in the next one. So we get fg plus t, which is minus mg into j cap plus t into j cap. Now bring this j cap outside. So the remaining is minus mg plus t. So that can be written as t minus mg. Okay, so this is how we represent any free body diagram and we write the equation in this form. Yes, clear with this example? So same way we are going to see with one more example, which is example 3.9. The question is, apply Newton's second law for the object which is rest on the earth and analyze the result. So object is what? It is resting. Okay, so since the object is resting, what are the forces acting on that? Generally when the object is at rest, upward it has a normal force, downward it has a gravitational force. Same way here also, see here. So this is the object which is at rest, upward it has a normal force and downward it has a gravitational force. Yes, this normal force I am writing it as N, and the gravitational force which will be writing it as M into G. And as we know, when we compare with the x and y axis is not there, only x axis. So we'll be writing this as N J cap, and this is again minus J because this is in the negative direction. So in the downward direction, this is minus J cap. Okay, then so this equation, if you are going to write, you'll get the equation to be free body diagram, object, normal, and mg. Fg is equal to what? Minus mg. N is equal to, because this is moving in the upward direction. So when you add this, you get F is equal to minus mg j cap plus n into j cap. Same way here also we can bring j outside, or we can write as it is. Okay. And what is the condition is? There is no acceleration. Why it is no acceleration? What is the question is? The object is at rest. So since there is no acceleration, what? A is equal to 0. A is equal to 0, and hence f of net is, we are going to add this both. This A is equal to 0, but F is equal to what? M into A. If you are going to substitute this A is equal to 0 here, F becomes 0. So this is 0 and this term as it is, but we are just taking this J outside and writing the equation as it is. This condition is why we are applying this condition, since the object is at rest. Yes, clear with this condition? Yes. So that equation can be written as just J alone, we are taking it to be 0. So minus mg plus n is equal to 0. Now bring this term to other side. So we get n is equal to m into g. What is n? Is a normal force, and mg is what? The gravity. So we are writing it as the normal force is equal to gravity when the object is at rest. Yes, clear? Then next we are going to see with the next one more example. What is the next example we are going to see here is identify the forces which are acting on the blocks A, B and C. So we are having 3 blocks here. This is A and this is B, and the next block is C. So for these 3 blocks we are going to see what are the forces acting. So generally we know, first let us see one by one. General thing is, for the block A, whenever you are considering for only one block, so this is a block A, it has the 2 forces, is it not? So what is the 2 forces? First one, normal force. Next is the force due to the downward force on the book B. Okay, so that is a gravity, the force due to gravity we can say. Next is the force on B. So when you consider the block B, there are upward force which is said to be normal force. Then it has a force due to block A. Block A nala or force. Then the downward force that is due to gravity, which is m into g. Okay. Next is the block C. So when you consider the block C, generally it has the 2 forces, which is normal force and the gravitational force, which is mg. Then again the force due to the block B. B exerts a force on the C, is it not? So the force due to the block B. So this is the forces which are acting on the 3 blocks A, B and C. So this is what I have represented with the help of the diagram. We'll just see this one by one now. First, force on the block A. First one is downward gravitational force and upward normal force, because that block is at the top, is it not? So it has only two forces, normal force and the gravitational force. So that normal force, I am just writing it as N of B. Then the gravitational force, which is mg into A, mg, m into G, but m I am writing as m of A. Okay. Then next is, we are going to consider for the next block, which is block B. As I've told you, this block B has three forces. First one is gravitational force and the normal force. So this is general. Next is downward force due to the block A. So இது சென்டரில் இருக்கிறதுனால இதுக்கு என்ன இருக்கும்? ஃபஸ்ட்டு ஒரு நார்மல் ஃபோர்ஸ் இருக்குமா? நெக்ஸ்ட்டு டவுன்வர்டு என்ன இருக்கும்? ஒரு கிராவிடேஷனல் ஃபோர்ஸ் இருக்குமா? மேலே இன்னொரு புக் இருக்கிறதுனால, அந்த பிளாக் இருக்கிறதுனால, பிளாக் ஏ இருக்கிறதுனால ஒன் மோர் ஃபோர்ஸ் which is said to be the downward force due to the block A. So that only is represented here. See here, this is B. This is gravity. So we are representing it here. This is a normal force. Normal force is represented here. The force due to the A, that we are writing it as N of A. Yes, clear with this block B. Okay, so in block B we have three forces. Yes, same way next one is block C. In block C also we have the three force. First one is gravitational force and the upward force, which is normal force, because any object, if you consider, it has the two forces, normal force and the gravitational force. And what is the one more force is? The next force is due to the block B. So that I am representing here. This gravity, I am writing it here, and this normal force, I am representing it here. Yes, clear with these examples? So if you are clear with the example, you will be able to write with all the other questions.